Hello student, today I will discuss about minors and cofactor of a determinant. First, I will write the definition of minor. Minor of an element Aij of a determinant is the determinant obtained by deleting its ith row and jth column in which element Aij lies. Minor of an element Aij is denoted by Mij. Suppose it is M and Ij. Suppose let A is any determinant. We have 4, 3, 2 and 1. Here it is an element A11, it is A12, it is A21 and it is A20. Here the minor of A11. The minor of A11. A11 is the 4 element. Then delete the corresponding row according to this 4. Then we called it is a M11. Delete this row and this column, it is 1. Then M12, correct, it is M12, we are at this 12 element. Then delete the corresponding row and column, which is 2. M21, it is this one, cross and cross, it is 3. M22, we are at here, then delete this and this, it is 4. Clear? This is the minor of a given determinant. Clear about the minors? If we want to find out the cofactor of a determinant, cofactor of Aij is, it is capital Ij. We denote cofactor as capital C or capital A. Generally we use capital A. Clear? Then suppose we want to find out the A11 cofactor of this. Then we will write this minus 1 raised to power 1 plus 1 with multiply M11. Correct? This minus 1 raised to power 1 plus 2, negative power 2, it is even. What is M11? Which is M11, it is 1. Same one. Correct? Same, we want to find out cofactor of 12. It is A12 or A12. It is minus 1 raised to power 1 plus 2 with M12. It is minus already because minus 1 raised to power 1 plus it is 3. It is 12. Then M12 we have, it is 2. Then we have value is minus 2. Suppose it is A21, it is minus 1 raised to power 2 plus 1. With M21, it is minus 1, M21 we have, it is 3. Then minus 3. A22, it is minus 1 raised to power 2 plus 2. Then M22. Correct? It is minus 1 raised to power 4, it is plus. Then we have the value of 24 is, it is 4. So this is the formation of how we find the cofactor of given determinant. Clear? Take one more example. Suppose let we have determinant, it is 2, minus 3, 5, 6, 0 and 4. 1, 5, minus 7. Clear? We know about the element of given determinant, it is A11, A12, A13, it is A1. They are the element A11, A12 or A13 we count with A13. It is A21, A22, A23, A31 and A32, it is A33. It is A33. Here, first we want to find out the minors. We represent by M11. Correct? M11 means it is the minus of A11 is M11. We can write it, or the minor of A11 is, we called it is a M11. We want to find out the value of M11. M11, just cross the corresponding row and go. Just press the corresponding, delete the corresponding row and column. Then we have how many elements? We have 4 elements. Just do the product of it is. Correct? It is minus 7, or you can say just we write the element. It is 0, it will have, it is minus plus 4, it is 5 and minus 7. We want to find out the value of this. It is 0 with minus sign, 5 4s, it is 20, then minus 20 of the value of M12 11 is, we have minus 20. We want to find out M12. M12 means cross this column, second column, first row. Then we have element of 6 4 1 minus 7. 6 4 1 and minus 7. It is 6 4 the minus 42 with minus of 4, minus of 46 we have. Correct? Again we want to find out the minus of 1 3 or 13, you can see. Then delete the row and third row, first row and third column, first row and third column. Then we have element of 6015, 6015, 6015. That find the determinant, it is 30 minus 0, which is 30. Clear? Similarly, you can find out all the related minors. Then how we find the factor of these? Correct? We want to find out the cofactor. It is cofactor denote, it is A11. It will be minus 1 raised to power, it is 1 plus 1 with the multiply of M11. We have a relation between cofactor and minors. How we find the cofactor of A11? It is minus 1 raised to power 1 plus 1 with the multiply as a value of M11. We have minus 1 raised to power, it is 2. M11 value we have already minus 20. Then minus 1 raised to power 2, it is plus. Complete answer we have minus 20. Here we want to the value of cofactor of A12. It is minus 1 raised to power, we called 1 plus 2, it is 3. The value of M12. M12 we have minus 46. Minus we have minus 46 already we have, it is plus 46. Then here we want to find out the cofactor A13, or you can say A13. It is minus 1 raised to power 1 plus 3 with M of 13. Minus 1 it is plus, then M13 we have a 30. So these are the cofactor of these related values, or you can find the cofactor of all the element of, you can find the cofactor of the all the element of the given determinant. So these are the minus and cofactor. Now after it we will discuss about adjoint and inverse of a matrix. Correct? Suppose here the adjoint of, first we will discuss about adjoint. The adjoint of a square, we need for adjoint we need only square matrix. The adjoint of the square matrix, which is A is equal to, we call Aij, is defined as the is defined as the transpose of the matrix which is Aij with n into n or m into n, you can say, where Aij is the cofactor of the element Aij. Correct? Adjoint is denoted by adjoint of A. Correct? Just take an example. Suppose we have any matrix. It is A11, A12, A13, A21, A22, A23, or A31, you can say A32 and A33. It is a matrix of 3 by 3. Correct? We want to find out adjoint of A. First we write it is A11, A12, the transpose of given element. A13, it is A21, it is A22, A, it is 23, A we have 31, A32, A32. The transpose of adjoint of the given matrix. After adjoint we will write it is row becomes columns. A11, A12, A13, A21, A22, A23, A31, A32, A33. This is the adjoint of given matrix A. Clear? Then after it we have a theorem. If A be any given square matrix of order n, then it is proved A into adjoint of A is equal to adjoint of A into A is equal to determinant of A into I. Here determinant of A is not equal to 0. Then here A into adjoint of A is equal to A adjoint of A into A is equal to determinant of A, I. Here I is an identity matrix and determinant of A is cannot be 0. Then if A is determinant of A is equal to 0, the matrix is, we called it is a singular matrix. We called it is a singular matrix. Correct? Then with the same time, suppose we have A into adjoint of A is equal to adjoint of A dot A is equal to determinant of A and I. Both sides I divide determinant of A and determinant of A. Clear? Then it is cancelled out. Then A into adjoint of A divided by determinant of A is equal to adjoint of A into A divided by determinant is equal to, we have I. Correct? Then one more relation we have, AB is equal to BA is equal to I. It means inverse of A is B and B of inverse is A here. Correct? Then what will be right here? Then A inverse is equal to B and B inverse we have A. Correct? Then we want to find out the inverse of a given matrix. Correct? Then B is equal to, we have, then B is equal to, we have, here we have a formula with A into A inverse is equal to I. Correct? Here I want to find out the value of A inverse, where B we have 1 upon the determinant adjoint of A, but B is equal to A inverse. Then A inverse is equal to, we have determinant of A into adjoint of A. Correct? Here determinant of A can't be 0 here. Correct? So this is the formula for the inverse of a matrix. How we find the inverse of a given matrix? First we need to find its determinant, and suppose we have, let A matrix we have, then we have it is 2, 3 and we have 1 and 3. It is 1 and minus 4, you can say. Correct? We want to find its A inverse. Correct? Find its A inverse. Then how we find A inverse? First we find its determinant. It is minus of 4 to the 8. Minus 8 with minus of, it is 1 into 3, it is 3. Minus determinant is, it is not equal to 0. Means A is a non-singular matrix here. Here it is a non-singular matrix here. Means A inverse is exist or possible. If determinant is 0, then we can't find the inverse of a given matrix. Then we have a determinant. We want to find out the adjoint of this. We have a formula for A inverse is equal to, we have 1 upon its determinant into its adjoint of A. For adjoint, we need to, how we find the adjoint? Adjoint of A is equal to, it is A11. We find the transpose of the cofactor of the element. Correct? Then adjoint of A is equal to, then we will find the A11. How when we find the A11? It is minus 1 raised to power 1 plus 1 into M11. We have M11 means it is minus 4. It is minus 4 because minus 1 raised to power 2 is 1. Here we want A12, it is minus because minus 1 raised to power 1 plus 2. The value of A12 means minus 12, M12. Cross cross, it is 1. Means M12, it is minus 1. Correct? We are at this. Delete the corresponding row and column. It is 3. Then we want to find out A21. It is 1. Cross and cross, it is minus 3 directly. I write. A22, it is minus 4. Cross and cross, it is 2. Substitute the values. We have minus 4. It is minus 1. 21 we have minus 3. 22 we have, it is 2. Clear? Clear about? So here A11 we recheck. It is A11 minus 1 raised to power, it is minus 4 is given. Then A12 already we have, A12 it is, then we have minus 1. Okay. Then A21 we are at 1. Cross and cross, it is minus 3, and we are at this, it is 2. Correct? But adjoint, do the transpose. Then adjoint of A is equal to, it will be minus 4, minus 1, minus 3 and 2. It is adjoint of A, but we want to find out its inverse. Its formula we have 1 upon its determinant divide into its adjoint of A. We have already one determinant value is minus 1 by 1 upon minus 11 into the given matrix minus 4 with minus 3, minus 1 and simple 2. So this is the inverse of given matrix. Clear? Then we have discussed about already minus, cofactor and inverse of the determinant and inverse of a matrices. Then we have a given question 13 in exercise 4.5. Then A is given 3, 1, minus 1 and 2. Then show that A square minus 5A plus 7I is equal to 0. Correct? First we will prove and find A inverse. Correct? Here inverse means we have already done, or we have already find out the value of inverse by applying elementary row operation. Alright, you can say we apply the row wise operation and column wise operation. Same in the exercise in matrices exercise 3.4. Same there we find the inverse, but here it is a different method. There we find the inverse by using elementary operation. Here we find the inverse with the formula. Correct? First we find the value of A square. Correct? A square means how we write A is A square is A dot A. First we have 3, 1, minus 1 and 2. Correct? It is same 3, 1, minus 1 and 2. Clear? Then we multiply. Clear? We multiply the row wise, it is what? 9 minus 1. Same we 3 plus 2. It is minus 3 minus 2. Same we have minus 1 and plus 4. Correct? Repeat, recheck again. It is 3 into 3, it is 9 with minus 1. Correct? 3 plus 2. Correct? It is minus 1 minus 3 with minus 2, minus 1 and plus 4. Then it is 8, 5, minus 5 and it is 3. This is A square. Then find it is minus of 5A, or you can say 5A. 5 into the given matrix, it is 3, 1, minus 1 and 2. Multiply element to element, it is 15 and 5, minus 5 and 2. 2 5s that it is 10. It is 15, 5, minus 5 and 10. Then it is 7i. Find the value of 7i. 7i, I denote here identity matrix of order 2 by 2, because the also the given matrix A is 2 by 2. Then we will, it is 7 0 0 and 7. Clear? Then substitute all this in the given relation left hand side. It is a square. A square we have 8, 5, minus 5 and 3. A square minus 5a plus 7i. We will substitute all the values. With the minus with 5a, we have 5a, it is 15, with 5 minus 5 with 10, correct, and with the plus of 7i, it is 7007. Then check, it is 8 plus 7 with minus, it is 0, correct. It is 5 plus 5 with 0, here it is 0. It is 7 plus 3 0 is equal to 0, means left is equal to right, correct. We substitute all these values in given expression. A square minus of 5a, it is 7i. Then so it is 8 plus 7 15, minus 15 0. 5 minus 5 0, it is minus 5 minus plus 5 minus 5 0, and it is 7 plus 3 10, minus 10 is 0. Then equal to whole 0, left is equal to it is right hand side, means it is true, relation is true. But same here, I want to find out the inverse. So to find the inverse, we will not we will proceed the same process. Which process? Means A inverse is equal to adjoint of A divide by determinant. Here we will follow, it is A square minus 5a plus 7i is equal to 0. Find inverse, means A inverse. I transfer A square with minus 5a is equal to minus of 7i. I transfer this thing into the right hand side. I multiply both sides with A inverse. It is A square, A inverse, it is A square minus 5 into A inverse is equal to minus 7i into A inverse. Then I break it, it is A into A inverse into A minus 5, it is I. A into A inverse we have I is equal